So I think some are removed from the meeting. Please try to join again, okay? So CR, you can just inform them. So last class we had seen about convolution integral. So today also we shall try to solve a problem where both are finite series. Okay. So x of t is given to be u of t minus u of t minus 2. Are you guys able to view the screen?
Yes, ma'am.
Okay. So h of t is given to be t into u of t minus u of t minus 1. Okay, this is the given question. You have to find the convolution integral for this. Okay, find the convolution integral for this given problem. So as you can observe, first whenever a convolution problem is given, try to check whether it's finite or infinite series. Okay, so if you see this, it's u of t minus u of t minus 2. So the signal will exist from 0 to 2 with an amplitude 1. So it's a finite series. Okay, so h of t is also finite because you have t into u of t minus u of t minus 1. So u of t minus u of t minus 1 is existing from 0 to 1 with an amplitude 1. So if you multiply that with t, you will have a ramp, a triangular waveform. Like you'll have a waveform like this, right? So both are finite series. So if you have such finite series, your convolution integral y of t will have 5 cases. Okay. So let us see, try to put this in the equation of convolution integral and try to multiply the equations. Okay. So y of t convolution integral is given as, can you tell me the formula for y of t?
Integral minus infinity to infinity x of tau into h of t minus tau d term.
Yeah, this is the equation for convolution integral. So in x of t equation, whatever you have to replace it with tau. Okay. And in h of t term, whatever you have to replace it with t minus tau. Okay. So integral minus infinity to infinity u of tau minus u of tau minus 2 into h of t term would be t minus tau into u of t minus tau minus u of t minus tau minus 1. Okay, so into d tau. So this is the equation we get. If we replace, if we try to write x of tau and h of t minus tau, x of t terms we are replacing it with tau, and h of t terms we are replacing it with t minus tau. Okay, is it clear till here? So you will have a minimum of 5 conditions. So we'll try to fix h of tau term and we'll try to vary h of t minus tau. Okay, so this is one term. Try to plot it and we'll try to plot this term also. Okay, so we'll try to plot u of tau minus u of t minus tau first. So we'll have minimum of 5 cases in this problem. So we'll try to plot x of tau, that is u of tau minus u of tau minus 2. So u of tau is nothing but unit step signal which is existing from 0 up to infinity with an amplitude 1. X-axis is tau. U of tau minus 2 is starting from where? U of tau minus 2. It will start from plus 2 and it will go up to infinity with an amplitude of 1. Okay, if you subtract these two, so you will get a waveform u of tau minus u of tau minus 2 will be a waveform from 0 to 2 with an amplitude 1. Got it, everyone? This is clear?
Yes, ma'am.
So we have to plot h of t minus tau terms. So what we'll do is, plotting this is difficult. So we'll plot h of tau first. Okay, what is h of tau? H of tau is tau into u of tau minus u of tau minus 1. Okay, h of t minus tau is, we are replacing tau with t minus tau. Okay, so this is h of tau for your information. So we'll try to plot h of tau first, then we'll plot h of t minus tau. Okay, so this is h of t minus tau terms. First we are plotting h of tau, then plot h of t minus tau. It will be easy. Okay, so h of tau is u of tau minus u of tau minus 1 into tau, right? Multiplied with tau. So first let us plot this, then we'll plot this, then we'll plot t minus tau. Okay. So first plot u of tau minus u of tau minus 1. U of tau is a unit step signal. It is existing from 0 up to infinity with an amplitude 1. And u of tau minus 1 is a waveform which is starting from 1, it will go up to infinity, okay, with an amplitude 1. X-axis is tau. So if you subtract these two, you will have u of tau minus u of tau minus 1. So this waveform will exist from 0 to 1 with an amplitude 1. So if you have tau into u of tau minus 1, what will you do? Tau into u of tau minus u of tau minus 1. So how will this signal look? At 0, tau is 0, x-axis. Okay, imagine if t is equal to 0. If t is 0, you will have
Ramp signal, mom.
Yeah, it will be a
From
ramp
0 to
signal.
1.
Correct. So at tau is equal to 1, you will have 1. Okay. So you will have a signal like this. 1 and 1 amplitude. Okay. Did everyone get this? How did we plot tau into u of tau minus u of tau minus 1? At tau is equal to 0, it is 0. At tau is equal to 1, it is 1. Okay. Got it, everyone? What is tau into u of tau minus u of tau minus 1? Is it clear?
Yes, ma'am.
Everyone, it is clear? So this is h of tau, which is nothing but tau into u of tau minus 1, u of tau minus u of tau minus 1. So let us try to plot h of t minus tau. Okay, this is h of tau, what we have plotted now. Now let us plot h of t minus tau. So how will you plot h of t minus tau? This is your h of tau. H of t minus tau means, how will you plot? You have to tell me how you will plot that. This is h of tau. How will you plot h of t minus tau?
Minus infinity to t.
No. H
Ma'am,
of
first
tau.
First h of tau minus t and
tau-
then minus of that, ma'am.
H of tau plus t or tau minus t?
tau plus t, ma'am, then time
Plus
reverse.
t.
Yeah. First you will plot h of tau plus t. First plot h of tau plus t, then time reverse that to get h of t minus tau. Because our x-axis is tau. Okay. So plot h of tau plus t. How will it look? So it will be like this. If you have so you will have a waveform like this. Just a minute. So this is h of tau. H of tau plus t will be like this. Correct?
Yes, ma'am.
So this is t and this is t plus 1 will assume. Okay. The width is 1 unit. Here also the width is 1 unit. You have 0 to 1. Here also you have, if you give values for t, if t is equal to minus 1, if t is minus 1, here it will be 0. Minus 1 plus 1, it will be 0. Okay, if t is equal to minus 2, so t plus 1 will be at minus 1. If this is at minus 2, this will be at minus 1. Okay, so if you give values of t, you have to get width 1 only. Okay, that is h of tau plus t. Now we'll time reverse this to get h of t minus tau. So h of t minus tau will be something like this. Okay, so this is t minus 1 and this will be t. So this is 1 only. So we have maintained the width of 1 unit. So if you give values for t, so it will be the same. If t is equal to 1, you see, if this is t is equal to 1, this is t minus 1. So that will be 1 minus 1, it will be 0. So if this is at 0, this is at 1. Okay, if t is equal to 2, so if this t is equal to 2 minus 1, this will be at 1. Okay, 2 minus 1 is equal to 1. Did you follow, everyone? The width of 1 unit is constantly maintained. Got it? It's clear?
And both will be right hand side, no ma'am. T minus 1 and t.
1 minute. Yes, tell me.
And
You're
both
telling me it
on
will be
right
from
hand
here
side.
to here, from 0 to this one.
Greater than 0, t minus 1 and t. It will be shifted a little more right side.
You can write like this also. As long as your width is maintained 1 unit, you can write like this, or you can take
You
like
can
that
write
also.
after 0 also, no ma'am. Both.
Yes, you can write, but width should be maintained. Here you'll have t minus 1, here you'll have t. Okay, or you can do like this also, like that also. Okay.
Yes, ma'am.
So our width is constantly maintained. We have plotted what is h of t minus tau. So our waveforms of interest are h of t minus tau and x of tau. What is x of tau? It is existing from 0 to 1, 0 to 2 with an 0 to 2 with an amplitude 1. This is x of tau. So these two are our waveforms of interest. Okay. So we are fixing this and we are varying this with respect to this. Okay. Understood, everyone? Shall we start the convolution? Till here,
Yes.
clear? Clear, everyone? So if it's clear, we'll start the convolution. Take case 1. These two are our waveforms of interest. Okay. Always take these two as reference. This is fixed and varying, and we are varying h of t minus tau. X of tau is fixed and we are varying x of t minus tau. Okay. So case 1 is when t is less than 0. Okay. So when t is less than 0, what happens? You have a waveform from 0 to 2 and t is less than 0. Here you have t is less than 0. Here you have t somewhere and here you have t minus 1. So what is the overlapping space? This is of 2 units and this is of 1 unit.
Ma'am, a t minus 1 amplitude is t, no ma'am.
Where? No, this I'm taking like that only. This waveform. So you should have 1 unit width. Okay,
No, ma'am,
t to t
amplitude
minus
of
1.
t minus 1.
Amplitude, yeah, amplitude is 1 for both.
T, no
Okay.
ma'am. T minus 1.
No, see here we have seen, right, what is the amplitude of our signal? It is 1 only. Just this will vary, width will vary, amplitude will be 1 only. Okay. Got it? This is our signal, h of tau. H of
Yes,
tau
ma'am.
plus t we are doing. Just shifting, that's all. We are not doing anything with amplitude. Amplitude is the same, one only. Okay. So if you see here, this amplitude is also one only. So what is the overlapping space? This is of 1 unit. Okay. This is of 2 units. So what is the overlapping space? There is no overlapping space. So y of t is equal to 0. Got it? It is clear? Why are you guys silent? It's clear.
Yes, ma'am.
Now go to case 2. So keep this diagram with you only for reference. So case 2 is when t is between 0 to 1. Okay. So if t is between 0 to 1, for example, you can take 0.5. How will the signal look? So you have from 0 to 2. This might be 1. Okay. This is 0. Okay. Here it is 0. So if t is between 0 to 1, you will have a signal like this. No? Got it? So this is t, this is t minus 1. So if you assume t is some 0.5, if this is 0.5, this would be 0.5 minus 1 minus 0.5. Here, t minus 1. So what is the overlapping space? What is the overlapping space?
0 to t, ma'am.
0 to t is the overlapping space. Okay, so we can take y of t is equal to integral 0 to t. What do we have here? In our problem, we have t minus tau. This amplitude is 1, this amplitude is 1. We are just having t minus tau into d tau. Okay. I hope it is clear. So we have to integrate from integral 0 to t minus tau into d tau. So integrate this. What will you get if you integrate? You have t tau minus tau square by 2 with limits 0 to t. So put upper limit and lower limit in place of tau. So that would be t square minus t square by 2 because lower limit is 0. So what is your y of t? It's t square by 2. Got it, everyone? Clear?
Yes, ma'am.
So now take case 3. Case 3, t is between 1 and 2. Okay. So if t is between 1 and 2, so what happens to this waveform? So you have 0 to 2, 0, 1, 2. T is between 1 and 2. So you'll have a waveform like this. So here you have t, here you have t minus 1. So what is the overlapping space? What is the overlapping space? I hope it is
Ma'am.
clear. Yes.
Ma'am, are we shifting the t value, ma'am? Like t minus 1 to 1 we have taken, no, ma'am. That one.
This is the same, no, h of t minus tau. This is.
Yes, ma'am, but down in the figure we have written in right side, no, ma'am.
Where? This one.
No, ma'am, down. Now what you wrote, ma'am? Last one. Yeah,
Yeah.
in this one, ma'am.
Yeah. In this.
It should be from minus 1 to t, right, ma'am?
What is minus 1 to t? So
Ma'am, like
see,
h of t minus tau, it should be from minus 1 to t, right, ma'am?
this one h of t minus tau.
Yes, ma'am.
No, it will be, see, width of 1 should be maintained. If this is t, this is t minus 1. Okay. So width of 1 is maintained. Here also width of 1 is maintained. Here also width of 1 is maintained. Got it? So one of the pointer is t, other pointer is t minus 1 for you. Got it?
Okay, ma'am.
So we are trying to slide this signal upon this fixed signal x of tau. Okay, firstly t will be less than 0, then t will be between 0 and 1, then t is between 1 and 2, so that this h of t minus tau signal is sliding upon this x of tau signal. So what is the convolution? We have to check at each stage. Okay, what is the overlapping space and find the convolution integral at that point of time. So see, this signal was previously here. Now it's first case it was t was less than 0. Then t was between 0 to 1. Then the t is between 0 to 2, 1 to 2. Next third case t is between 1 to 2. That time t minus 1 will be here between 0 and 1. Yes or no? So if t is, consider if t is 1.5, what will be t minus 1? It will be 0.5, right? If t is at 1.5, t minus 1 will be, t is 1.5, you imagine, t minus 1 is width of 1 unit. So 1.5 minus 1, it will be near 0.5. Correct? Are you guys following? So check the overlapping space. What is the overlapping space?
t minus 1 to t.
The overlapping space is from t minus 1 to t, right? So your y of t is equal to integral t minus 1 to t minus tau into d tau. Okay, now integrate this and tell me what you get y of t. So you have t tau minus tau square by 2 with limits t minus 1 and t. You have to tell me what you get. So if I put upper limit, so you will have t square. Yes.
Ma'am, limits will be from 1 to t, right, ma'am?
See, this is the overlapping space. It is overlapping from here to here, right?
Ma'am, but we have taken value from 1 to 2, right, ma'am?
Yeah. So if t is between, if t is between 1 to 2, t minus 1 will be near 0.5. What is the overlapping space? Multiply these
1
two
to t,
signals.
right, ma'am?
No, t minus 1 to t, right? How 1 to t? You are leaving this part. Our whole ramp signal is inside this rectangle. What is the overlapping space? Whole ramp signal is overlapped inside this rectangular signal, correct? So it is from t to t minus 1. If t minus 1 was somewhere less than 0, then it's not overlapping. But t minus 1 is also overlapping with this rectangular signal, right? Both t term and t minus 1 term both are inside this rectangle. So the overlapping space is from t minus 1 to t. Yes or no? So only I told you, if t is 1.5, we are taking t between 1 and 2. If t is 1.5, t minus 1 will be 0.5, right? 0.5 is inside this rectangle only, no? So overlapping space is from t minus 1 to t. Got it?
Yes, ma'am.
Okay, now you try to put upper limit and lower limit and try to get the integration. So you have t square. If I put upper limit, you'll have t square minus t square by 2 minus, if you put t minus 1, you will have t into t minus 1 minus t minus 1 whole square by 2. Got it? Now solve this.
And
So
is it minus 2t square plus 4t minus 1 by 2?
you will get half. Just check
Yes, ma'am.
once.
By 2, ma'am, whole by 2.
1 minute. Here t square minus t square by 2 is t square by 2 minus, this will be t square minus t. Yes, if you multiply this, t square minus t. Yes or no? Minus, you have I'll take half here. So t square plus 1 minus 2t. This is of a minus b whole square. A square plus b square minus 2ab. Okay, so now we will try to solve it and we shall see what we will get. So we have t square by 2 minus t square minus t square by 2 minus half plus t, right? Yes or no?
Yes, ma'am.
So minus t plus t gets cancelled and t square minus t square by 2 is t square by 2. So t square by 2 minus t square by 2 plus half you will have. So this and this gets cancelled, you will be left with half. Got it? Got it? What is your y of t?
Yes, ma'am.
Clear everyone?
Yes, ma'am.
So this is our y of t when t is between 1 and 2. Okay? If t is between 1 and 2, this is our y of t. What we have got. Next case is case 4. T is greater than 2. Next case. Okay? So next case, case 4. T is greater than 2 and your t minus 1 is between 1 and 2. T minus 1 which is less than or equal to 2. So we have 0 to 2. So they are telling t is greater than 2. So t minus 1 is between 1 and 2. So this is how it will look. And now you check the overlapping space. What is the overlapping space? So t is greater than 2 and t minus 1 is between 1 and 2. Got it? So check the overlapping space. What is the overlapping space? Are you guys following?
T minus 1 to 2, ma'am.
So overlapping space is from t minus 1 to 2. Okay. So y of t is equal to integral t minus 1 to 2. Okay. So you have t minus tau into d tau. Now integrate this with respect to the limits t minus 1 and 2 and tell me what you get. So if we integrate with respect to d tau, you will have t tau minus tau square by 2 with limits t minus 1 to 2. Okay. So put upper limit and lower limit and you solve it. So we have 2t minus 2 square by 2. This is tau. I'm putting 2 in place of tau, upper limit. In place of tau, put 2. Minus, in place of tau, you put t minus 1. Okay. So 2t minus 2 square by 2 will be 4 by 2. Minus, you have t into t minus 1. T into t minus 1. Minus t minus 1 whole square minus by 2. Okay, you solve this and tell me what you will get. So you have 2t minus 2 minus t square minus t minus, if you take half common, you'll have t square plus 1 minus 2t. Correct? So you have 2t minus 2 minus t square plus t plus half t square minus 1 by 2 minus t, right? Yeah, minus t. Now you tell me what will get cancelled. Plus t and minus t will get cancelled. So minus 2 minus 1 by 2 you have here. So you have 2t. So minus t square plus t square by 2 will be minus t square by 2, minus t square by 2. And if you add minus 2 minus 1 by 2, you will get minus 3 by 2, correct? So take LCM. So it will be 4t minus t square minus 3. This is your y of t, correct? Got it, everyone?
Yes, ma'am.
Is it clear? What is y of t? If t is greater than 2 and t minus 1 is between 1 to 2. Okay, clear this case. Take next case, case 5. If t is greater than 2 and t minus 1 is also greater than 2. So your signal is from 0 to 2, x of tau. So next our signal is moving forward. Okay, so you have t and t minus 1 both greater than 2. So what is the overlapping space y of t? It is not overlapping, right? So y of t is 0. So these are the 5 cases for finite signals, finite sequences. Both x of tau also finite and h of tau also finite. Got it, everyone? It is clear?
Yes, ma'am.
So we shall just brief up once again whatever we have seen. So this was the question we tried to solve. Both finite sequences, x of t, it is u of t minus u of t minus 2, and h of t is t into u of t minus u of t minus 1. You have to find a convolution integral, that is y of t, for both these sequences. So y of t is a convolution of x of t with h of t. Because it's continuous time signal, you have convolution integral. Okay. So integral minus infinity to infinity x of tau into h of t minus tau into d tau is the equation for convolution integral. So now x of t terms, you have to write x of, what is x of tau? So for writing that, wherever you have, whatever is your x of t, replace t with tau. So you have u of tau minus u of tau minus 2. Okay, I'm replacing t with tau, that's it. Multiplied with h of t minus tau terms. H of t terms, replace it with, wherever you have t, replace with t minus tau. So here we have t, replaced with t minus tau. Here you have t, replaced with t minus tau. Here you have t, replaced with t minus tau minus 1 you will have. So this h of t minus term would be t minus tau into u of t minus tau minus u of t minus tau minus 1. Okay. So we'll try to plot these two. So first, this is first term, that is x of tau term, u of tau minus u of tau minus 2. This is u of tau, which is nothing but unit step signal. It starts from 0 and it will go up to infinity with an amplitude 1. Because it's u of tau, our x-axis is tau. Okay. Minus u of tau minus 2. You have u of tau minus 2. How will you plot that? This is right shifting because your constant is negative. So it will start from 2 and it will go up to infinity. So x-axis is tau, constant is minus 2, so it is right shift. So the signal is shifted to the right by 2 steps. Okay, if you subtract these two, you'll have a signal from 0 to 2 with an amplitude 1. Now we have to plot this one, that is h of t minus tau term. So what we'll do is, first we'll plot h of tau. Okay, h of tau is tau into u of tau minus u of tau minus 1. We are replacing we are replacing t with tau first. Then we'll do t minus tau. Okay. This h of tau term will be u of tau minus u of tau minus 1 into tau. So we'll plot u of tau minus u of tau minus 1 means it will start from 1. Okay. So if you subtract these two, you'll have u of tau minus u of tau minus 1, which is the signal. existing from 0 to 1 with an amplitude 1. Okay. If you multiply tau to this signal, at tau is equal to 0, the signal will be at 0. If tau is equal to 1, the signal will be at 1. At tau is equal to 1. Okay, so this is your signal, h of tau. Now we have to plot h of t minus tau. How to plot h of t minus tau? First we'll plot h of tau plus t. Then we'll take time reversal of that to get h of t minus tau. Okay, so this is h of tau. So h of tau plus t will be like this. Okay, so it will be from t plus 1 to t. Okay, I'm taking t and t plus 1. Okay, because I'll be varying this signal. So time reverse that, you will get a signal like this, t to t minus 1. You have to observe one thing here. The width is 1 unit. Here also it is 1 unit. If I time reverse also it is 1 unit. The width of 1 unit is maintained. Okay, so I'm fixing this and varying this term with respect to this. Okay, so that is what, where you will get 5 cases. Okay, so if t is less than 0, if t is between 0 to 1, if t is between 1 to 2, if t is greater than 2. Okay, t is, we are moving this, we are sliding this signal upon this signal. So you have to know what is the overlapping space properly. So we'll have 5 cases because both are finite sequences. So case 1 is if t is less than 0. If t is less than 0, there is no overlapping space. So convolution integral y of t is 0. So in case 2, our t has moved little forward. This has moved little forward. T is between 0 to 1. Okay. Yeah, so it is between 0 to 1. So if you see the overlapping space, it is from 0 to t. This is the overlapping space. So 0 to t, t minus tau into d tau. So if you integrate this with respect to d tau, you'll have t tau minus tau square by 2 with limit 0 to t. So put upper limit and lower limit, you'll get y of t. Then our t has moved one step forward still. So it is between 1 and 2. T is between 1 and 2. So t minus 1 will be between 0 and 1 because it is of 1 unit width, right? So overlapping space is from t minus 1 to t. This is the overlapping space. Okay, so integrate this t minus tau with respect to tau. You will have t tau minus tau square by 2 with limits t minus 1 to t. So put upper limit and lower limit. If you put upper limit, you will have t square minus t square by 2 minus t into t minus 1 minus t minus 1 whole square by 2. Okay, so solve it carefully. So t square minus t square by 2 will be t square by 2 only. Minus, multiply this, t square minus t minus half into t square plus 1 minus 2t. This is of a minus b whole form, a minus b whole square form. So now you try to multiply these. Okay, so t square by 2 minus t square minus t square by 2 minus half plus t. Because 2t by 2 minus into minus plus, you will have t only. So try to solve this here. These two will get cancelled. Minus t plus t. So t square minus t square by 2 is minus t square by 2. You will have half here multiplied with negative sign is plus half. So this t square by 2 gets cancelled because it's plus minus. You'll be left with half. Okay. So be careful while solving these things. Okay. So next, our t has moved one step forward. It is greater than 2, but our t minus 1 is between 1 and 2. So this is the scenario. The overlapping space is from the overlapping space is from t minus 1 to 2. Okay, so integral t minus 1 to 2, t minus tau into d tau. So if you integrate this, you'll get t tau minus tau square by 2. It will be the same, just the limits will change for case 2, 3 and 4. So put upper limit 2 in place of tau, replace it with 2. You will have 2t minus 2 square by 2 minus t into t minus 1 minus t minus 1 whole square by 2. So when solving, you be careful. So 2t minus 2 minus t square minus t minus half into t square plus 1 minus 2t. Okay, so you have 2t minus 2 minus t square plus t plus half t square minus half minus t. Okay, so minus t plus t gets cancelled and you have t square minus t square plus t square by 2. So you have minus t square by 2. So 2t minus t square by 2 minus 2 minus half, you'll get minus 3 by 2. So take LCM, you will get this term. Next case, our t has moved forward and t minus 1 also has moved forward. T is greater than 2 and t minus 1 is also greater than 2. So there is no overlapping space. So y of t is equal to 0. Is it clear, everyone? So you write for all cases whatever you get y of t. You have to write this at the end. So for it was 0 for t less than 0. Okay, and case 2, what was the answer? It was t square by 2 if t was between 0 and 1, right? You write that. And case 3, it was half, right? If t was between 1 and 2. Then case 4, it was 4t minus t square minus 3 by 2 when t was greater than 2, t greater than 2 and t minus 1 between 1 and 2. Okay, so case 5 was 0 if t was greater than 2 and t minus 1 also greater than 2. Got it, everyone? It is clear? It's clear or not?
Yes, ma'am.
Everyone, it is clear?
Yes, ma'am.
What about others? So I'll give you one homework problem, you try that, else I will solve this tomorrow in tomorrow's class. Tomorrow we have at 8 o'clock now, you will solve it that time. Take this homework problem. So x of t is given to be u of t minus u of t minus 3 and h of t is given to be u of t minus u of t minus 2. Find the convolution integral y of t for this. Okay, you fix h of t and vary h of, so fix x of t and vary h of t. Okay, you try this. It's quite simple compared to this previous problem. You can write your name and USN. If you have any doubts, you can get it clarified. You have any doubts? So such problems will be asked for 10 to 12 marks, okay, whatever we have seen today. You have any doubts? Anyone?
No, ma'am.
Okay, guys. What about others? You want me to explain anything once again? If you have any doubts, get it clarified, else we can wind up this session. Thank you, students.
Thank you, ma'am.
Hello, ma'am. Can you share previous year question papers, ma'am?
Okay, I will share it to you. I'll put it in Google Classroom.
Okay, ma'am.